Hi, this is Mr. Shumway. This video clip explains how to construct the fourth point of a parallelogram when given only 3. So maybe I can show you what I'm talking about and then you can pause it. So if somebody were to give you 3 points of a parallelogram, so we can connect those points with line segments. And then the fourth point would be somewhere out here. So the line going from C to the fourth point would have to be parallel to AB, and the line going from B to this fourth point would be parallel to AC. We know how to make perpendiculars. Do we know how to make parallels? Well, 2 perpendiculars make a parallel. So let's try that. Let's try to make a perpendicular to one of these through this point, for example. And then we can make a line perpendicular to that one, and it will be parallel to the original one. 2 perpendiculars make a parallel. So I'm going to intersect that circle and this line. I get 2 points there. Intersect those 2 circles. I think I want to create a line, not just a segment. Now that I have this line, I'm going to create a small circle on that line from C, and intersect the circle and the line, and intersect those 2 circles. Go from C to one of those, or through both of those. Now this new line is parallel to AB. Now if I make a line parallel to AC, it will intersect this line, and we'll have our point. So I'm going to cut out a few circles. And I'm going to create a circle from B down, intersect that with this line, and intersect those 2 circles. And go, whoops, I'm going to have to move a little bit here. See the other one. Okay, now create a line between those intersections of those 2 circles. And then I need to intersect that segment and that line. Now I have a line that is perpendicular to this one. Now I need to make one perpendicular to that line through B. 2 perpendiculars make a parallel. So if I make a smaller circle from B, intersect that line and that circle, intersect those 2 circles, Okay, so maybe you can see the parallelogram. Um, I'm going to go ahead and intersect this line and this line. I'm going to hide a few circles. Maybe they'll show up a little better that way. And maybe eliminate a line. Is it J? Yeah, we don't need that one. Oh, we need I? Yeah, we need I. We need L. Yeah. We need F? No, we don't need F. Okay. And there's a whole bunch of points we don't need, but I think you can see the parallelogram at this point. So if I were to change one of those points on the original points, at least for at least for a small distance, I have that it still stays a parallelogram. Well, how can you verify that it's a parallelogram? We could measure the angles, like from C to A to B. That should be the same as from B to A to C. And you can see over here on the left, yes, they are the same. That doesn't necessarily mean that these others will be, but you might be able to guess that they will be. So yeah, so as I change, oops, I only have a slight range that I can go because the circle runs off the end of the segment. I guess I could have made a line instead of a segment. But anyways, the angles stay the same, stay congruent. The alternate angles. What have we done? We have constructed the fourth point of a parallelogram when given only 3.